All right. Hello, everyone. Thanks for joining. We're going to talk a little bit about project ontology development. So this time we are going to focus a little bit more about the kind of conceptual thought processes that go through your mind when you are building and planning a project ontology. And I will discuss and I will describe to you a little bit, like, first of all, what this is, how it's different from like a normal domain ontology, and what kind of use cases there are for these kinds of ontologies. So it's a little bit slightly more conceptual than usual. I will show some examples for you to dig into, but it's one of these things that you can't really demo very well because they involve often lots of terms, and it's quite hard to run them in a live tutorial. But I think you will probably get a good sense afterwards. So let's just first of all talk about this weird term, project ontology. So why project ontology? Like, no one has ever used that word ever, and it doesn't really mean much outside of today's tutorial. But why do we use it? So we were, for like many years, we were using this like weirdly overloaded term application ontology, which is still quite widely used for this kind of case. But whenever we are talking about application ontologies and like we're in different contexts, like with other people from around OBO, there are completely different ideas of what an application ontology is. So we try to coin, let's say, this project ontology notion, but we can also rename this if someone comes up with a better idea for this concept of an ontology that is developed like an application ontology for a particular use case, but is mostly just a conglomerate of various other ontologies that you pull together, and they are used. And the kind of like key distinction here is that, or what I write here as a defining feature is that project ontologies, by their very definition, are not meant to be used as domain ontologies. So they're not meant to be reused, for example, by another ontology downstream. So you wouldn't see an import statement to a project ontology in the wild. So project ontology developers have much more freedom when they're building their ontologies. They can slice and dice, delete and add relationship, change labels in whatever way that the use case demands it. And I will show you concretely like what kind of use cases there are to do such things. So generally, in practice, processing and adding new things should be and is usually quite minimal, because if you're in like well-developed environments like OBO, so if you're pulling in ontologies, you don't usually have to kind of like do lots of after massaging to integrate this information into your own project ontology. And very often it's really nothing. It's just like, you know, taking all these different pieces from different ontologies and merging them together. But again, don't worry if you can't follow what I'm saying right now. To some of you it will make sense, but you will get a better sense when we get through this tutorial. I just want to make sure that you understand what I mean by project ontology here, because this word is really rarely used for anything out there. So it's an ontology used for a particular use case and not intended for reuse. Okay, so prerequisites, of course.
Nico, can I stop you for a second?
Yeah.
Of course, I have a question. I always do. When you said they're not meant to be reused, I understand what you mean, but is the goal to basically have an ontology, and let's say like that this quote unquote ontology, is it that it fits whatever we want to do at the moment with our project, or is there some sort of underlying goals that somebody else could reuse let's say, the way we made it? Maybe not the data itself, but you know.
So
did you understand my question?
Yeah, absolutely. Okay. So when I say reuse, I mean literally it's not intended for other ontologies to import it. But of course, like when you're developing a project ontology, it is very interesting for other people with the similar problems to reuse the whole project ontology. Like, for example, one of the big ontologies that we are developing in Monarch, which is Finio, is a classic project ontology for, let's say, integrated phenomics. And here the hope is that people that have a similar use case, working and integrating data for phenomics, would be able to just simply reuse the whole ontology, but also the infrastructure if it's relevant. The point really is you are deliberately open to change the contents of the ontology. You can hack it, add axioms in it, change the labels, slash the definitions. You can change whatever you want. You do whatever you want with it. There's nothing that can keep you from this information because it's not meant to be reused by someone else. Ideally, you shouldn't change the label. That's a bit of a thing, especially if you're using it for curation purposes. But it is theoretically allowed, let's say, for these kinds of ontologies.
Okay, thank you.
I will show you some examples. It will get a bit more clear when we come there. Okay, so generally, so I will talk mostly here about, we will start with a little bit of motivation. I should refresh the page. Yeah, so we started a little bit with motivation. So what are these ontologies? What are they used for? And then I show some architecture diagram, and then we will go a little bit through like the 3 main ingredients of project ontologies and the 5 major phases of project ontology development. All right, so why do we need project ontology? So there are many, many different use cases. I'm just cherry picking a bunch that kind of relate to most of the people that are here on the call. So we have, for example, use cases around the area of semantic integration. So here you have, for example, curated a lot of data or integrated a lot of data from various resources, and you wish to add some semantic fabric on top of that, which is provided by an ontology. So concretely, you may want to, for example, add, like that's what we do in Monarch, for example, a bunch of ontologies and their interrelations on top of our knowledge graph to be able to query the knowledge graph, for example, through higher level ontological groupings. So you will be able to look, for example, for all of the anatomical entities that are part of the cardiovascular system. Yeah, so this is the kind of things you need in for these kinds of queries. You need to add the semantic layer on top of your data, which may relate, for example, anatomical entities to genes for gene expression. There are other use cases, like, for example, semantic search. So you want to restrict a certain widget, for example, to searches for diseases. You want to be able to understand what kinds of things is a user looking for right at this moment, not just, parsing lexical tokens. So we have, I think that some of the people in Monarch are working very hard on like getting a good version of a semantic Solr index up and running using Uber graphs, for example. But I'll show you some just so that you get like a very basic idea. Like this is, for example, from Open Targets, their user interface. And we have this in Monarch as well. I just want to show something else, not always only just Monarch. And you can, for example, if you see, you have this UI where you can enter a search string, and when you start typing, you start typing for Marfan, and what you see down here is you see like categories of things like diseases or phenotypes, related drugs, drug targets, and all this kind of thing. So it already understands the kind of like the semantics in this sense, or at least presents a bunch of different groupings to the user that are based on the semantic categories from the underlying ontology. And similar, we do this also in Monarch Initiative and many other search indexes. So examples, ontologies in this area of semantic integration are, for example, Finio, which is the ontology that underlies the Monarch knowledge graph. EFO, probably the most famous application ontology in our area, the experimental factor ontology, which is underlying basically everything, all the kind of data resources of the European Bioinformatics Institute, EBI. And another ontology developed by ABI, the Atlas ontology, which is basically an ontology that is used for indexing data for the single cell atlas. And we will go through how these are used a bit later in this tutorial. Another big use case other than semantic integration is, someone is checking the chat, and you also just, the deal, just interrupt. I mean, it's super informal. If you want to ask and add something, if you think that I'm saying something wrong, if you just want to add something, just unmute yourself and interrupt me. You don't have to, it's not a formal tutorial or anything. Okay, so another big use case is natural language processing. I have to admit, I don't know very much about how ontologies are used exactly in natural language processing applications, but the kind of like general intuition is that you may want to use ontologies to tag specific phrases in your documents with ontology terms to make them searchable by ontologies. Like, for example, all the things that are relevant to COVID, you want to look for COVID relevant symptoms and even genes or organism information in a corpus of documents. So the annotation use case here, the annotator use case, not to overload this word annotation even more. Here the ontologies very often serve as something like quite sophisticated dictionaries, like where you have a term with many different synonyms, and these can be used, for example, as a way to match certain words in text and link them to ontology terms as part of a wider, for example, named entity recognition process. Ontologies that are developed for this purpose are like probably the biggest category. There are many different ones, even some that were recently submitted to OBO, which causes a bit of trouble for some people, because some say that these kinds of ontologies really do not belong in OBO. But here, this is an ontology that one of our developers, Harshad, has put together recently for NLP related process, so the Bero ontology, and EBI again has developed this or actually it was developed by some collaborators, and EBI helped with the technical parts for NLP in coronavirus literature. But there are sand in the sea, many project ontologies developed with this kind of mindset behind it. And then lastly, just another example, because it's so important to me personally, that's kind of the thing that I mostly do. So we also develop these kinds of project ontologies to facilitate mapping work. So in this case, for example, we put together an ontology that of like all the different clinical terminologies out there, like ICD and disease ontology and Mondo and Ordo and OMIM and all these kinds of different things. You massage them a little bit to unify some of their relevant representation, and then put them all in one big ontology, and that kind of makes it much more effective to do mapping work. Like you can, for example, feed this to a graph learning process, for example, to generate graph embeddings or node embeddings. Or you can just use this simply to open it and review mappings that you are generating. So you typically mapping tools, many of you have never worked with mapping tools, but typically mapping tools take as an input one big blob of axioms and return as an output some kind of like equivalence links between terms in this input. So you can use these nice integrated views also to check a bit, okay, these are linked together, how are the hierarchies looking, what are the consequences of these links, and so on. So that's kind of another big use case. So this is an example ontology that is doing that, the Mondo ingest application ontology, let's say. All right, that was motivation so far. Any questions? Does it make sense? Okay, I hope it does. So let's talk about the basic architecture of project ontologies. So try to take a kind of like bit schematic approach so that it seeps in a bit easier. There are some more complex pieces around the edges that I'm glossing here in this diagram, but I think it covers kind of like the intuition. And this is something that I hope really that you go away with today. Like, even if you don't go away with anything else, just to understand 3 major ingredients, 5 kind of major phases that are specific to project ontologies. So the ingredients, so the things we need to build a project ontologies are 3. The first one is what is called the seed. The seed is essentially a set of terms that you wish to import into your project ontology. So this seed could be something like, if you're familiar with ODK, you will have probably edited some of these files in the source ontology imports directory, like go_terms.txt, and you will have added some IDs to this term. So this is managing the seed for the Go import in an ODK, in a normal ODK setup. So this is one thing that you could do in other kind of scenarios. So if you followed, for example, Bill had some questions in the robot channel yesterday about how to import certain terms for a demo from HPO. And there we were talking about like providing a few classes as input and then extracting all of their children and a few relationships around them. So basically, when we're talking about seed, what we're talking about is some set of terms, and this can be described as actual IDs and selectors. So selectors are things like all their children, or somehow logically related to it, or anything that any descendant, any ancestor, all of these kinds of selectors, or simply all of them. So there are, so if you're looking at some of the ontologies like Finio, for example, the use case is saying we want to integrate all disease and phenotype information and add some other stuff on top of this. This means we just want to get all of the diseases. So this is kind of like a seed decision where we say all diseases and this subset of Go and this subset of Kebi, for example. So that's yeah.
Is the seed the list of term, are these ontology term, like quote unquote regular ontology terms? Okay.
Yes. So they are thanks for asking. These are IDs. So we are not in this pipeline here, we are not concerned with the question of going from like natural language kind of names to the ontology IDs that are then used to build the application ontology. So we are assuming here that that you already have an idea which terms you want to import. I'm going to show you one example in a millisecond where that illustrates this point of what happens if the input is something other than ontology terms a little bit, but this seed is really a list of terms. That's what this is, either explicitly as IDs or IDs plus some selectors. The second ingredient for project ontologies are the source ontologies. So when you plan your project, okay, you have made your kind of like at least a cursory idea of like what kind of terms do you need here. Then you go and decide which ontologies are you going to extract this information from. Yeah, so you make a bit of a choice. You use let's say DO for diseases, Uberon for anatomical entities, and so on and so on. So you make it this choice and say these are kind of the ontologies from which I want to get the information from a project ontology. And then lastly, you have, and that's the kind of last ingredient for, and the least important one, but still you should know it for project ontologies, and you should also conceptualize it really separately from all the other things, is the pieces that that you are going to add to your ontology, like what you would do in a domain ontology, which are things like ontology metadata. So when you're developing a good project ontology, you would have the same considerations to do like when you're developing a normal ontology, with adding version IRIs to them, adding titles, adding provenance, creator information, descriptions, all these kinds of things that you know from your wrestling with the obo dashboard, for example. All of these kinds of consideration obviously are the same here. So you should always kind of consider that there is a minimal amount of kind of like adding some kind of metadata related information in a project ontology as well. And then secondly, there are always some kind of customized axioms. Like there are, when I say always, I mean actually not always. Like I would say in maybe a third of the cases of application ontologies that I was involved in, there is some component where you add some custom axioms, inject them into the ontology. So for example, in EFO, this is a huge deal. Like this is so big that actually you could say that half the ontology is actually managed like custom axioms. But for other ontologies, like for example, Sciatless ontology or Finio, there is literally zero additional axioms. And these kind of axioms are things like, from my experience, where you want to kind of link terms from different ontologies together, but they are not quite linked in their source ontology. So you want to provide links between, you have, let's say, sort of diseases maybe for multiple disease ontologies, because your use case requires that somehow, and you have to add some subclass of axioms between them, or you have some kind of upper level manual curation where you want to put everything under BFO, even though your imported ontologies do not have any BFO alignment, or COP. You want to put everything under COP, and all of these things. You may want to massage it a bit and add some additional stuff. So that's kind of the third and last ingredient, axiom customizations. Okay, so about ingredients, does it make sense so far, or do you have any questions about that?
I guess I'm not sure, like, why you would edit this. Why isn't it read only?
Yeah. So you mean why would you add additional axioms in your project ontologies that are not covered by any of the ontologies you're pulling in? Is this your question?
Yeah, and why wouldn't you add those axioms back to the main ontology alternatively?
Yeah. Very excellent question, and I have actually a separate paragraph later in this thing about this, but I'm just going to say this right now. So in all application ontology projects that I've involved in, like, one of the key non-functional requirements is speed. So you don't, like, developing a proper ontology takes lots of time. Like adding a single term to Uberon can take weeks. It's not a fault of Uberon. It's just in the nature of the kind of the problem that you want, that you need to discuss with the community. Is this really an appropriate term? Is the classification appropriate? Is the label the right label? Is the definition clear enough? All of these things just require lots of iterations and conversations. And when and many project ontologies that are being developed really are like, we need this stuff fast. So we need to have we want to do an NLP experiment yesterday, and so we put it together and do anything necessary so that we can run this experiment. So speed is one thing. And the other thing is, and this is something, actually, let me show this to you. So if you look, for example, at the Mondo ingest, that's, I think, really a very good example for why you need to actually physically change some of the inputs. So I'll show you real quick. So I know some of you will have not done much ODK. You must have listened to one of the tutorials at least. So remember, there's a makefile and there's a makefile extension. The makefile extension allows me to kind of define some custom processing code. So, and look at this. So here we import, we look at the OMIM ontology, we're pulling the OMIM ontology in, and what the first thing that we do are actually, or Ordo, or NCIT, or DO. And the first thing we do is actually, we have to normalize this ontology. Like there are so many things in these ontologies that need to be, that are like that if you want to put them together and you want to query across them, this is not a matter of like wrong or right or something like that. Yeah, so for example, good example is prefix usage in hasdbxref. Of course, it would be great if the whole world would agree on one prefix map, but that's just not the case. So for example, I've tried a bunch of times with the DO to convince them not to use the OMIM prefix for OMIM PS, like the phenotypic series, but it's a big churn also for the OMIM development team to change this now, because maybe their users expect their cross references with OMIM : instead of OMIM PS : which is what other ontologies like Mondo do, for example. So there's always some requirement to go into these ontologies and normalize them so that the whole is afterwards usable as one harmonized, consistent thing. So that's kind of like how I would think of this. So I can show you one example query, for example. So here, this is the fix OMIM PS query. So what it does is it looks for the occurrence of OMIM : OMIM PS in hasdbxref and replaces it by OMIM PS : So that these kinds of processes are very often necessary to achieve integration between for a project ontology. This can never happen, obviously, for a domain ontology, but this is what you do for project ontologies. Does it make sense?
Yep, thank you.
Any other question? Or was someone else asking something?
That was something similar.
That's okay, great. Okay, all right, so now we've covered the 3 ingredients. Now let's move over to the 5 phases. So the 5 phases that are specific, these are not all of the phases involved. I exclude things like release pipelines, continuous integration, because they are kind of the same as in all of the ontologies, but these are the 5 central phases that you should plan when you're planning your project ontology project. Very nice. I already realized how beautiful this name project ontology is. So the first phase is managing the seed. So how do you actually write this down, and how do you add it somewhere, and what do you do and plan this? Then how do you choose a suitable extraction method? So this is kind of, there are many, and it's very hard sometimes to see which one's the right one. And you will be disappointed to learn that that neither is there the right one, nor is there a really good one. And then how do you manage your metadata and customizations? Then the merging and post-processing, and then lastly validation, which is slightly different from your usual ontology development projects. All right, so let's look at managing the seed. I'm going to do this with, I think, with a single cell atlas ontology as an example. All right, so how do you manage seed? So first of all, before I go and show some examples, there are many, many different ways to manage the seed, to figure out the kind of terms that you need. So for example, you can say, and that's like the use case of single cell atlas ontology, for example, I only want the terms that are used in my data curation pipeline, nothing else. Or I only want those terms plus their parents or something like that. Now, so what this means then is the input to your seed extraction or seed definition problem is actually a dynamic dump of a database which contains all of the IDs that this particular project has curated to. So I'm just going to hope that this is all checked in the repo, but let's take a quick look. Oops, wrong. So here, for example, in SciAtlas ontology, what's happening is that there is a process that that is managed by some group somewhere, that is using a, I don't know how these tools are called. Let's call them annotation tools. I don't know, maybe that's the right word, that where the curators feed a bunch of natural language labels to a tool called Zoomer, and then return and then get like a bunch of ontology terms in response. They go through it and say, this is good, this is bad, this is good, this is bad, this is good, this is bad. And then the curated set of ontology terms that come out of this process, like the curated ontology terms, let's say, they provide this to us as like an input. So they give us a URL. This is where you can get this from. And then what we do is we run some kind of a process, and that process extracts all of the IDs that that they have used anywhere to annotate anything. And you can see all of these different kind of IDs, thousands and thousands of IDs that were used across the corpus for something. Yeah, so the seed management here is completely driven by the use in the curational database. So rather than thinking, oh, I need this, I need that, I need that, the input was already given to us. These are the terms we need. So it made seed definition much easier in this case. Another example, of course, is EFO again. EFO is based on user requests. So rather than using annotated data, EFO relies on the fact that they have like some major users like GWAS, for example, GWAS catalog, and some others that will come to it and say, we need this term, please include it in EFO. And then if this term already exists in one of the imported ontologies, then the EFO curator simply pull this in, for example, from HPO, like increased head size or something. Then they will pull it from HPO and then add it into EFO. Or they get like a list of terms and say, we need all of these measurement terms. And then they check, okay, some of them may exist, but most of them don't. So we just bulk add them all into EFO. A bit questionable practice, but yeah, let's not comment on that. Okay, and then what we said before, there are some use case specific considerations where we say we just want simply everything, and then from this and that ontology. So we don't really need to, when we are defining our seed management strategy, we really just say, so for example, I'd show you in Finio, which Harry has put together very nicely. You can see you just say in your config, just give me like basically all of these ontologies, like pull in the whole of Pato, pull in the whole of Ufino, pull in the whole of Mondo, and so on. Yeah, so this is the kind of what you didn't do concretely, but today is not so much about concrete. This is just to give you a sense. Okay, so this is the phase managing your seed. So you figure out what are the depending on your different use cases, what are the terms that you need to pull in, and you may have to think about like, okay, maybe I need to also add descendants, parents, or other kinds of related classes to your seed as a post consideration. But for now, just write it down. How to extract them. This is will be covered by the next phase. So this is really about understanding and defining. These are the things I need to have in my project ontology. All right. So then the next phase is then the module extraction process. So basically, we've talked about this a few times before, but the goal here is we need to somehow. So I'm going back to the picture maybe. We need to somehow, given our big source ontologies that we have selected, like let's say Uberon, HPO, and Pato, we need to somehow extract the subset from these ontologies that is relevant to our current use case. In some cases, this may be the whole ontology. In other cases, it may be only the terms that are dependencies of ontologies that we pull in as a whole, or it may be a list of terms that someone provided in a data set, whatever, it doesn't really matter. In any case, we need to extract these subsets. And the problem here is that what is a subset or a module in this case is very ill-defined. So we have like very confusing discussions on Slack all the time. What is that? Like, what is that? First of all, it's already confusing because subset has a specific meaning in OBO, which it makes it also more annoying to use, because subset is such a natural term to use for a subset of something. But unfortunately, this term has been used for some very specific construct in OBO ontologies as well. But what I mean is, like, let's say a part of an ontology. And what the problem here is that there are many different ways to get to these parts. So a very naive and very widespread thing is to think in terms of terms. So you're saying, when you're saying extract me a subset, what you are thinking in your mind is extract me the terms in my seed. But you realize really quickly that that's not really enough, because obviously if you get the terms from your seed, you also at least want the interrelationships between these terms from the ontology that you extract from. So it's not enough to just get the terms with, like, for example, robot filter, but you also want to make sure that you get the parentage between these terms included as well. And here's where the trouble starts. If you're using before I go there, let's just talk about, because it's a really, really important issue here. Let's talk about the kind of three major families of existing and the one big family of non-existing extraction algorithms that we have right now. The first big one are the logical modules. We sometimes call them slime modules. And slime modules are the modules that we use for continuous integration and domain ontology development. Why do we do that? The reason for this is, so modules like this, what they do is you provide a seed, you say, I want to import term A and B, then the extraction algorithm will go to the ontology and then will extract everything it's anywhere in this ontology that could theoretically affect reasoning with these terms. So providing two seed terms may result in basically the entire ontology being included in the module. Now, this is useful for cases where the purpose of the module extraction is quality control for your domain ontology. So, for example, if I build an ontology of phenotypes and I'm linking to Uberon, then I want to make sure that that what I pull in from Uberon will be everything that is necessary. So if I make some mistake in my modeling, I want to be sure that the reason I will say this is an unsatisfiable class because you are not consistent with the representation in Uberon. That's why you really want everything, like everything that's somehow logically relevant from Uberon. But for project ontology, this is a terrible kind of module, like, because you want 5 terms and you get 500. Yeah, so it's insane how big these slime modules are. Unfortunately, they are still widely used, even for project ontology development, but we will go over why that is in a second. Then we have the filter modules. Filter modules are, if you know robot, this is basically just saying to robot, these are my terms, extract them from my ontology and maybe select also their ancestors or parents or something. So these are actually the ones that I use at the moment widely, not 100% ideal either. So I'm not going to go into much detail, but there is a problem with using filter modules when you expect that it preserves any relationship other than ISA. So you can't ensure that, for example, if you're extracting from like an anatomy ontology and you have like a partonomic chain, and in this partonomic chain, you extract something from the beginning and something from somewhere in the middle, you can't be sure that in the filter module that you get out, you will still have the fact that these two things are in a part relationship, because filter doesn't really know how to deal with these kinds of existential restrictions in ontology. So very incomplete kind of module, still the best for many of the application ontologies that don't necessarily need to preserve these kinds of relationships, for sure. And then we have myriad modules, which is a bit of like a sore in my eye, but it's a very widely used module type where you say, give me, I want this, anything between this term and that term, pull it all in. And when it says pull it all in, it really just goes up and down the subclass of hierarchy. So it's in the end, it's kind of less good, in my opinion, than robot filter, but many people are still using it because it's easier to just say, here is my root term, give me all of the descendants, and then you have your module definition. So people are still using this as a way to extract a module from a source ontology. All right. Okay. So one last word on this section here. One thing that you should keep in mind is the word ontology in project ontology is very often not helpful when you're designing your project ontology process, because actually most of these use cases we talked about before, like NLP, semantic integration in knowledge graphs, maybe except for this mapping work thing. So these two big use cases up top here, they kind of like don't really care whether what we are giving it are ontologies in the strict sense, like ontologies in OWL sense of the word, like with weird, complicated logical definitions and EQs and various disjointness statements. All this information, all these semantics of the ontology is lost the moment it is fed into these upstream systems. There is no disjointness in disjointness reasoning in any case in a knowledge graph, not like the one that you would get when you're using ontology. Okay, there some, if you're very smart, you would say like, oh, you could blah blah blah. There are some reasoners that would do it, okay, but in 95% of the cases, semantics of relationships and semantics of or disjointnesses and stuff like that is just lost. So sometimes it's not quite useful to think of these project ontologies in terms of they have to be like OWL axioms. Better to think of them as sort of a mini knowledge graph. And that said, I just want to point you to the fact that I make some comments about this later here, that you could even plan a project ontology sort of as like a mini knowledge graph type project. And indeed, Harry and his group are exploring actually at the moment how a kind of more knowledge graph based thinking methodology would work for building such project ontologies. And I put some links here to, for example, to KG Finio, and you can, and it's cool because he's developing both these ontologies at the same time, like one with ODK and one with like more knowledge graph type methodology. And you can really see side by side what the differences are. So I'm encouraging you to take a look at that.
Nico, there's a question in the chat.
All right, go ahead.
It just says, how is that related to SLIMs?
Okay, probably back to back to the subsets.
Yes.
Yeah, all right. Now you've put me on the spot. Like these kind of terminologies make me really make me highly annoyed. So I think so. I know that, let's say, SLIMs are used usually for like display purposes. For example, when you're looking at these ribbons in that you see on the Go pages, where you see, for example, let's say that I have annotations in this area of the ontology saturated. There's no annotation in this area of the ontology, blah blah blah. So these kind of gene ontology ribbons, they're fed by SLIMs. I think like I think that slims are just literally value sets. Like they're literally just they're like lists of terms that can be used for some particular purpose. But maybe there's some, let me just look at the participant list. That's someone that may be more able to answer this question. Is there no David here?
Maybe there's a kind of an overlap there too with when you're working with something like an NCBI slim, because that's going to be, you know, kind of a chunk of the taxonomy, and that may only be, you know, relevant to a particular domain.
I hear you talking about that. So I'm not even sure whether this was named correctly, but anyway, yeah. you may be right. Yeah. So he's talking. So let me just. So there is this. That we are all using this because NCBI is so huge. So look at this, just the naming of this, just so that we are clear. Okay, there is a folder called subsets in NCBI taxon, and in there you see the tax slim. I'm not even sure that this is the right name for this thing. So yeah, and in any case, it's a good question.
Is that a slim or a slime?
No, that's a slim. Different.
Okay.
Slim and slime has nothing to do with each other. Okay. Slim is a notion from like gene ontology sphere that refers to a set of terms. That's what I know. But it has also some kind of functional purpose, which I forgot now. Slime is a kind of module extraction algorithm, different level of abstraction. So I'm sorry for not being able to answer your question, Bradley, just perfectly, because the slims and subsets, they are always a bit like, like, I don't know. Sometimes I really don't know exactly the difference. But yeah, let's leave it at that maybe for a moment. Or did you want to, Ray, do you know the difference exactly?
I'm not sure, but my experience is that so a slim is a subset of a single reference ontology, but an application ontology is sometimes a mixture of several slims from different. So for example, for single cell or the human cell atlas, so it has different kind of components, different slims, and that is an amalgam of different, is in that. So that is how I look at it, but I might be wrong. So
yeah, so maybe kind of like, maybe a slim is sort of like a seed declaration in some sense that can be used for some purpose. So let's say you have like, you're in the human slim, let's say, from Uber on. This is all the kind of like terms that are sort of related to human, maybe something like that. But let's get a good answer for this for the whole group and circulate it later. I think you're in somewhere in the right direction there, Ray, but we should get a better answer to this question. All right, just a few more minutes left. We're almost at the end in any case, so I'm just gonna browse through this parts. So the last thing about the extraction process that I want to mention is they are all bad. And it's a big problem that we don't have a good module extraction algorithm for modern application ontology development. And we have now a proposal in that is in robot that is scheduled to be merged in a month roughly, which can do at least like a sort of myriad extraction that is able to bridge across all of the different relationship types, like including part of and develops from and all these kind of different relationships. But even that is not like 100% ideal for many use cases. Like some use cases are really complicated where you say, like, for example, what Bill was asking yesterday, look, I want all of these terms, but sort of also the things that they are related with. Very hard to specify in any sort of way what that means. And yeah, and that's why this is sometimes not ideal. And that's sometimes why people like me still use slime modules actually for project ontologies, because in this cases, you're at least sure that you get all of the relationships, even if you get a billion relationships too many. Okay. Now let's look at the last two phases. So we have managing the metadata and customization. This is similar to what you are doing in your normal ontology development projects. So like literally the same considerations. Always make sure your ontologies have a nice title in Protege, like not just outside in the GitHub repository, but they have a license, they have a title, they have a description, all of these typical metadata things that you know from Obo Foundry dashboard type stuff. Should always be there. You should always have a versioning strategy and use version IRIs for your ontology. And if you're using ODK, you will get all that, but just, you know, even if you don't use ODK, just make sure you have that as well. It's not that if it's a domain ontology, you only use it when it's a domain ontology. You really want to apply this kind of fair semantics thinking for all the ontologies that you're developing. And this links here to the question that Sierra asked in the very beginning. So if you have to, because of time constraints for your project, like do things like quickly add terms to your ontology, quickly, because, you know, your use case requires it. I just need 50 new terms. I'm just adding them now, boom, boom, boom. But theoretically, they belong into Cabby. Theoretically, they belong into HPO, but I just can't go through this huge process of adding them to HPO. It's really like, you know, think of it like this. You are saving 1,000 hours of work by reusing all these different ontologies for building your project ontologies that you use for your application on the one side. On the other side, you need 20 minutes to make a ticket and maybe 3 hours to debate a bit about some things at the relevant ontology trackers to get all of these terms push upstream where they belong. And if you add relationships, think of it the same way. It is really something that you need to think about when building these ontologies. You add stuff, think to contribute to the proper domain ontologies. Stuff that you add into your domain, into your project ontology is worthless from an ontology standpoint. No one will and should be using it. Okay, that's it. All right, so the last phase then in the ontology, sorry, there were two more phases. So we have the merging phase and post-processing phase. So the merging phase is similar to what we've learned in the ODK tutorials. You take all of the extracted modules. So let's go back to the picture maybe. So you take all of these extracted modules that you've extracted from your upstream source ontologies, you merge it with your ontology metadata and potentially these kind of little bits of glue subclass axioms or some additional terms that you have had to integrate to accommodate for your use case. You merge all this stuff together and apply potentially some post-processing and generate a big project ontology. So typical things like that you do in post-processing here are things like stripping out irrelevant kinds of OWL axioms that are still there, like disjointness axioms and stuff like that. In particular, if they may be causing unsatisfiable classes. Again, you're not building a domain ontology, you don't care about OWL, you're free to create unsatisfiable classes, just do not integrate them into your final product. So if you put incompatible ontologies together, that's up to you, but do not make sure that the final product that you create does not have unsets in it. And the way that you do this is you delete all of the axioms that could cause unsets, like disjointness axioms, for example. And then you do typical annotation stuff like adding version IRIs and so on. Okay, lastly, you can read about, like, I've just started with this, so there's no content about the frameworks that exist. There are many different there are people like James Overton who are rethinking this whole process of application ontologies and try to build like an application ontology kit that is entirely in the browser. So you get all of your source ontologies, you click the terms together that you want, you say, I want this children, that children, that children, click a button, boom, 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 and then you get your application ontology out on the other side. You can use ODK, obviously, like we use for most of the projects in our realms. So just wanted to say that before the time runs out, but I didn't write much about this, so I just don't want to go into much detail. But validation is one thing I want to mention. So when you're doing when you're building normal ontologies, you have like really serious validation. All of you know this. Our pipelines break all the time because people put two labels, because people added subclass axioms where they shouldn't, or add wrong logical axioms that cause unsatisfiabilities. But this kind of things do not really apply for project ontology. So what you should think of when you're designing a project ontologies is how do you evaluate this with regards to your use case at hand? And one ontology that James Overton and I, for example, are currently working on is a project ontology for Critical Path Institute. And here what we do is, so it has like a bunch of disease and assay terms from various ontologies and phenotype terms. And what we do here is we define competency questions in terms of Spark queries and generate synthetic patient data, stick it together with the ontology and just ask the query. So we look for all of the patients that have been diagnosed with some form of scoliosis or one of its subtypes, or more whatever query you have to provide with regards to your use case. So it's really useful when you design your validation strategy, first of all, to design one, because I see people just not doing that when they are building application ontologies, because they think, I don't care about logical coherence, but what you really care about is your use case. Design them by providing competency question in the form of Spark queries and see that these competency questions get answered. So that way you can make sure that when you're making a new release, that your ontology is still able to answer these competency questions that are relevant to your specific use case. Okay, that's all I wanted to say. Is there any final questions that you have?
I know we don't have time today, but is the process for updating a project ontology already documented that I could read?
It's right now it's the same as a typical ODK, with a bit of caveat. So I wanted actually to get a proper process up for today, but I didn't have time to completely document it. When you're asking how to update it, are you talking about like how to update an ODK based setup in the sense that you can add a new term to it, or what exactly do you mean, like making a release, or
just keeping it in sync with its parent, for lack of a better word, ontologies?
Yes. Now the concerns are exactly the same as for normal ODK setup. So you follow the normal ODK process. So if you were to simply run make, prepare, release, all of the updates would be run automatically. So all the new terms are pulled in, the terms are synced, the labels are synced, the definitions are synced with the upstream sources. Afterwards, everything is post-processed, merged, and thrown out at the other end.
Okay, thank you.
Any other questions? Yeah, exactly.